the recording.
Wait, are we in the recording like us?
Yeah.
Oh shit. Okay. Should be, maybe I should be eating or whatever.
Fine. Um, so let me just kind of recap on what I am doing. Let's see, which window do I want? Chrome. This one. Okay. So I'm kind of documenting the basic architecture. Can you guys see my screen?
Yeah.
Yeah.
So I've kind of gone back and forth, and this is kind of some of this is not new, but I'll just kind of go over it. The basic architecture. So we have the client side architecture, and the client side is the browser. And if you imagine that Babylon JS is running in a browser, that's a game, that's an experience, but it's by yourself. So we're always going to maintain this philosophy that to have the fastest experience, you want to run it in the client as fast as you can, but it would be a very lonely experience. So I'm going to kind of go over client side and then server side and how they kind of communicate. So first, a client will request a URL for a specific space defined by a slug. And we've seen this before. This is kind of like, so it'll be the XR space will be the new URL, and maybe this will be the slug. Okay, so that's a particular experience, and people can create their custom spaces and then share the URL. The client will load that URL and then load a unique experience. So a web page is rendered. It's going to give back some HTML. There's some script tags in there that will load an application bundle.js as well as dependencies such as Babylon.js and maybe WebRTC, all the kind of dependencies. So that's pretty typical. And then the first thing we want to do is we want to create a WebSocket connection back to the server so that we have some way of communicating with other clients. Okay, so this is stuff I've done before. You've seen it before. And this is kind of what I want to spend some time on is the specification. And I'll talk about what a specification is. So a specification for the unique space is loaded and parsed. So this is just like it identifies what's in this space, what makes it different from another space. The thing that's unique about the space is the specification. So the specification can specify plugins. So plugins are initialized and loaded as necessary if specified by the specification. So a plugin would be like another dependency. For example, if the application is app.js, that loads almost bare bones nothing. But depending on the specification, you might load another JavaScript bundle that's like avatar.js or movement.js or screenshare.js or webrtc.js that enable additional ability. And the reason why I wanted to do that is because I don't know what kind of fundamentals we need, and then we might version those fundamentals. So maybe somebody is okay with a space just creating box. You're like clicking on stuff and you're creating boxes, and maybe you don't need voice, maybe you don't need monsters, and then so you don't have to load the entire everything, right? We want to have it very modular. So that's kind of my idea there. What the application does is it ties all the plugins together. So it will bootstrap the plugins. So the engine, which is Babylon.js engine, and we'll create a scene and a camera and bootstrap all the plugins, tie them together. And we'll kind of go over through the definition of what a plugin should look like. And then once you get the specification, I guess that's one of the plugins. So the scene graph is populated based on the, I guess, scene loader plugin, which is part of the specification. Okay, so all that's saying is the client side is going to load some JavaScript and parse some stuff and load up Babylon.js. And that gives us an experience. So what's in this specification? So a space has a very modular design. Every aspect feature is controlled by a plugin so that these libraries can be swapped out or upgraded independently. And if certain spaces do not need certain capabilities, then that code will not be parsed unnecessarily. So some examples of plugins might be WebRTC Sound or an avatar system, scene parsing itself, persistence, shared communication with other spaces. For example, the ability to share messages between um, spaces, like spaceships flying in a shared universe, or maybe a gun system, a health system. So certain fundamental systems that are required for games. So a specification will have a list of plugins that need to be loaded. So it might be something um, like spec, and then maybe like plugins, and then it has a list of plugins there, maybe. Um, so let's see. One of the plugins can be called Space Loader, and I took some inspiration from A-Frame. So part of that specification, um, I don't know if it should be a plugin actually. Maybe it's just part of the. I'm not sure. So a space specification has a list of plugins, but part of that specification could be, yeah, maybe it's a plugin. Maybe it's not part of that specification. Maybe because maybe you can load several uh, scenes. Maybe so. Maybe this is a scene loader or something. So this is kind of like A-Frame, where they have these kind of HTML tags, and then you can put different fields on them. For example, if I go to A-Frame, whoops. Here you have a 3D scene, and if you view the source, uh, it's taking you to a server. Hold on, let me go to their documentation. Where's their documentation? There we go. Okay, so here's their scene. So I kind of like this because it tells you declaratively what's in a scene, and it says there's a box, there's a sphere, there's a cylinder, and these are the positions, and these are the rotations, and this is the color, this is the height. So it's very easy for people to set up something in their space. But what this isn't very good at, or they have a way of doing it, but then you have to go into create code, is the behaviors. Like, can you move something? That's a little bit tricky to specify. So I'm just taking inspiration from this, but and I still like Babylon JS better. But I was thinking of slideshows. Like when you create a PowerPoint presentation, you put stuff on an empty page, and that's one slide. And then you kind of copy and paste that to slide two. And if you move some of those things around, when you go between slide one and slide two, it's like it animated a little bit, right? Every frame of the slide is almost like a keyframe. So things can be defined by entities. Like you can say, you give something a name, and it can have a source, which is a GLB file, some uh, file that you created in 3D software. It can also have these components on it, like position and rotation and scale. And XML or HTML gives you this ability to nest them. That's intrinsic to the document model. So you can just say, oh, this is a parent of this. So by nesting them, it's often more succinct than JSON in that regard, that JSON doesn't have parent and child. So you would have to say, oh, this is a list within that object or something like that. So we could have some things that are grouped together, like states for the different slides. So imagine you're creating something like red light, green light. So you could say, here's a collection of that's an ID. And within states, you have many child elements. Each one is a state, singular, and they have a name, and then they could have more entities inside them. So this one could be like the head, that doll, and it can have some rotation. And then like CSS transformations. So CSS has animations as well, but it's declarative animation. So if you look at CSS declarative animation, the way they handle animation is kind of like with classes. So you say, I want to move this in some way, but it's when you apply the class to an element that it starts doing this. So it will transform it, and this is how fast it's going. And then they also have some easing. So you could say, oh, the animation is linear, so it stays the same, or it kind of slows down at the end, or it kind of eases in, so it slows in and then it might slow out, or this is ease in and ease out kind of thing. So CSS animations are for very simple things. It's kind of like only when you hover over something, or it doesn't really have sophisticated stuff. But I actually think this is a good place to start for recreating kind of like HTML slideshows in 3D. So we could group together the full state. So in here, you list everything in the scene that you want for that particular slide or state. So in the going green, you could say, this thing is going to animate over half a second and play a sound once, and then you can have another state that's like green light, where like it turns all the floor to green. Then you can have another state that's like going red, it plays some other sound. Another state that is like red light, where the floor is red, and so for every state, it's kind of you use the same analogy as when you're creating PowerPoint. You copy everything that you want for every state. So it's a very declarative way. If you want it to end up on, if you send a message, show me the state green light, you just draw everything that's grouped together under that state. But when you transition between states, if something was removed out of the next slide, then you just you hide it or you remove it, right? So that's, I think this is a good format for web developers. Maybe not everybody can do this, but I think this gives you a good way of actually changing the scene, where um, something like A-frame doesn't give you the ability to do this, but if you group them together, then we at least have a specification for what's different between slides. So we can also have simple components. So these are kind of like where you want to end up. I want to end up with rotation here. This is how fast I want it to move. But you can also move to a state where, oh, this thing is just hovering. It's like maybe going up and down, or maybe it's spinning and it has a spin speed. And then on the next slide, I want to stop the spin. I just remove these components off of those elements, right? Oh, the thing is still there, but because you remove those components, I know I need to stop the spinning, right? So it might be verbose, because you have to, if you have like a bunch of things, dozens and dozens of things that you're managing, then you have to copy them to every state. But it is fully declarative. It's not like do this thing. It's just this is the state of the world in that space. So I think it's very straightforward versus an imperative kind of state where I want you to add this class, or I want you to remove this, or so we don't use any verbs like that, right? I'm not telling you to remove anything or stop anything. It's just like, this is the state, this is the state, this is the state, this is the state. And so far this specification doesn't say how you get into the state. I'm merely saying what states are, grouping them together, and then I'll talk about how we get into states. So one of the things that HTML components have are like on-click events, right? So we could have simple behaviors that are VR related. Like on point is when you take the pointer and you like you fire at it, right? You click your trigger button. That's an on point. And on push might be when you make a finger gesture and you like push into it, like pushing a button. On grab might be that you intersect with it and you hold the grip button. That's an on grab, like you're moving something. And so we would be able to send messages. So we could have some very basic messages, such as change the state. And this could be the name of the next quote unquote slide, right? So back here where we defined states and we have these different states, we could say change state to going green. And this would do some events. We'd send the same message to every client that's connected to say, change your state to this. Then whatever state they're in, they're going to say, oh, what are the things in this state? And then go play this sound, or go rotate this. It'll do the DOM diffing, quote unquote DOM diffing, which is like, what's different in this thing and what do I need to change and how fast should I transition it? So I think this is a pretty lightweight to do, but this doesn't give us the red light, green light game. And that's what I was trying to get into the specification. So far, I think this stuff is pretty easy. Like we can manage this because it's just stuff that's there and some really lightweight cause and effect. When I do this thing, send this message and change the state. So I think we could do this. Like this is a pretty good specification for an experience. It's a very simple experience. So you could have meetings in here and then very lightweight behaviors like I click this button and maybe lights come on or sounds play or these things slide up. And I think that's pretty cool. That's more than a lot of spaces. But it doesn't get us all the way there, because if you're playing red light, green light, this kind of message originates from the client. I had to do something in order to change the state, and it's changing the state for everybody. But if you think about red light, green light, when that thing is going red light, green light, it shouldn't come from any player. It comes from the server side event, and we haven't talked about that yet. And also things like, let's say, remember that game I had with the random balls dropping from space? Like, where do those come from? If that were described on the front and you had something like, oh, random ball coming out, it's, first of all, it's hard to describe what that thing's doing because there's time involved, there's some randomization. And so if every client runs it, they're going to get a different idea of random stuff falling down. And it's also it's just hard to describe behavior. So I think state is okay to describe. So I separated all the stuff that's declarative for the front end, where I think it's easy to describe. But if you wanted a game that's doing that, I think we need to put that on the server side because it's responsible for sending messages for everybody that doesn't originate from a single client. Stuff like the game is started. Because why should any one player say it's starting? Because if every client was observing, oh, we need 5 players, and the 5th player just joined, so I'm going to start the game. I'm going to tell everybody else to start the game. If you have 5 players, every client side thing is competing to say start the game now. So it's a lot of redundant messages that are going across that. So I think certain things like that managed state should live in a gen server. And the thing I was struggling with is how could I make a generic gen server that served every kind of circumstance? It became very kind of rather hard to write and hard to test. So I think that we should have specific gen servers for different kinds of things. Everybody still with me? Any
Yeah.
questions up to this point? Does that make any sense?
So like if you keep states on the client side and you keep you're gonna create modifiers of those states on the server side, how do you keep the two in sync? Like it seems like You have a list of things that you define on clients, and then you're gonna write stuff on server to modify the list. The list. It seems like these two things should be together, not far apart. The way it's defined now, they're pretty far away from each other, right?
Yeah. Um,
Like if I was to change red light, green light to red light, yellow light, green light, I'd have to add states and then perhaps rewrite a bunch of stuff on server to go from red light to yellow light. Like these changes may not even go in. Like, do you envision them going into our code base together? Because one is perhaps just a text file, or like you said, a string somewhere. The other thing is perhaps some programs that we have to write. And to me, they need to be committed together for things to work, right? Because otherwise, I just create yellow light state on the client side, add it to the file, and then there isn't anything on the server side to handle that change.
yes. So I think maybe that example is not a good example of, because we prefer not to separate a game into front end and back end. I agree, it makes it kind of hard to manage. So we can have an API for the front end that allows drawing or creating new objects when it receives a message, and create the game part of red light, green light um, on the server side. So the server side can call a message, hey, front end, draw me a doll, and here's the model for it. And then when it receive movement, I'm gonna like this person is dead, right? So yeah, we try not to split the definition of a game into different parts. If there is a game that's required, we'll try to write it in the gen server, and then the gen server will create its own geometry and manage its life cycle there. But for the basic meetings or slide show type of things, they'll write that in that specification, and then they can animate that a little bit. But anything more sophisticated, write it in gen server. And so probably the developers are the only ones can do that, or contributors that want to write a gen server and add it to the code base. But I
So
think it's powerful in the sense that a space might be able to run multiple gen servers, like supervised, and then you could have, like, let's say poker game, and you could have a table here playing a poker game, and it's run by one gen server, but you have another table running its own poker game, and it's running another gen server.
So let's I guess we can start simple, like a presentation. Like we create a space where I'm the presenter and you guys are the audience. I'm presenting a slideshow,
Yeah.
right? Like,
Yeah.
and I click my pointer, and the slides will move on my command.
Yeah.
Are there concepts like roles, permissions, in the sense that I'm the only one that when I click my pointer, the slides will move, where you guys are simply just observing, right? Like you're just sitting down and not doing anything.
Yeah, that's a very good question. So I thought that maybe that can be in the specification. Let's see, where is my window? For example, let's say, yeah, let's not call this red light, green light. Let's just say presentation, and let's call this slide one. And then maybe this is, yeah, this is just a Earth model, and then it's like, when you transition here, it's playing a sound. Maybe it's like spinning, spin, whatever. And then, so the thing that captures these things, maybe you'll have.
You're not sharing your
Oh,
screen, by the way.
sorry. Doo -doo -doo. Can you see my screen?
Yeah.
Okay. So let's say you have
Yeah.
this
Yeah.
slide one. Then we can have something like simple behaviors, and that needs to be attached to something. So maybe down here, you can say something like you can have an entity, which is just a transform node, right? It's nothing, but it has a name. Um, Slide controls or something. And then you could have a particular component. It's just like host only true or something like that.
I
We'll have
see. I see.
some way. And then in here, you can have like entity, and it's like go to one or something, and then on point it goes change state to slide one kind of thing. So only they can do it, or maybe it's like even invisible, or maybe only they can see it, or maybe it's like um
So even in the states or in the specification, I can have one entity do something to another entity. I can create the controls where I can define, click on point for this thing. It will go to something that's defined somewhere else in the spec, which is fine. Yeah, okay,
I think you can have multiple of these things, right?
right.
And then this is not inside this, so this is not affected by those transitions. So you can say you can have maybe you have to say the which presentation and then which slide. So this can be presentation, like for example, presentation one. This is presentation one, and maybe you have like two slideshows or something, or and like you start one, and then maybe and it's like speaker one controls this one, right? And then you have like another slide deck that's like speaker two, so then they go and control this one potentially.
I see.
And you only need to mention or have those entities for which you're animating or removing. Those things that are like the ground, the audience, the arena that are not part of the presentation, you just specify them outside of this. Like maybe all of this goes into an assets thing. It's just data, right? But they're not actually part of the scene graph until it gets a message. Like it has to receive one of these states, and then they get drawn into life, and they're managed by the transition machine. So your base entity, like all the stuff that's in the scene, that's like maybe inside a scene node that's got like chairs and all that other stuff, is not affected, and it can't be affected by the transitions, but it can have the on click on change stuff. So you can like do stuff to it. But I suppose if you wanted it to have any kind of change, it would be cool to have those entities inside these slides, because you could click something, push something, and it might highlight for everybody, or it might start spinning for everybody, or disappear for everybody. But if you didn't want it, if you wanted it to always be present and not subject to the state machine, then just put it outside, I guess. So that's the thing with the specification, right? So you can mention sounds that are inside the state, and when you transition, just like CSS animation, it will invoke that when a class is applied. Here, we invoke stuff when the state is applied. So if you had a sound, it will play once, but you could also have a thing like play continuously. So maybe when you enter this slide, it's playing like music on a loop. So as long as you stay in that, it'll just keep playing. So we can do that kind of stuff. And certainly there's some entities of an entity library that we can pull in that have their pre-baked behavior. And then for example, maybe a gun has a gun system, and that kind of ties into that plug-in system where people's health get deducted and you'll be killed. But I think that will those will be things that we write for people, and it's a lot more sophisticated than these simple cause and effect things.
And we haven't gotten to like states that are tied to individuals, right? Like whether it's a presenter or an audience, right? Like if it's a gunplay, like I shoot you, your state will change and Bobby's state won't, right? Like these are individual states. We're not there yet.
Right,
okay,
not there. So that's a good point. I think that will all be handled by server-side architecture. So I'm saying that when you go into the realm of games and you need to contain sophisticated state, and the reason to hold state and variables like how many people do we have, how many people said that they're playing, what is the health of people, then it starts getting too complicated to describe in a declarative style. You need expressions, you need conditions, you need loops and logic and some of those crazier things. So I don't see a way of easily expressing that, because I was going down, can we write this in JSON? And it was just so verbose, like, oh, if this and this, and trying to write that in JSON or XML was just crazy hard. And I don't see, like this I could see us coming up with a specification for, but then that logic, it just seems like there's a whole bunch of bugs, and that's much harder. So I think we'll just
do you consider using step function things? They're essentially a state machine with conditions and transitions.
No, you're talking about the Amazon step functions.
Yeah, the Apache. What was their? I forgot their templating language. I think Apache something. I forgot. But
Apache velocity template or something.
Yeah, maybe.
Okay. No. But I also don't like those velocity templates. But anyway, okay. So this kind of stuff, I think there are some reusable types of server-side logic that we can mix and match. So rather than thinking that for example, one of the reusable things is game start or end for a particular game. And for red light, green light, this is kind of like a closed timed session. And the distinction is that people can't come in continuously, right? They're starting at a starting line, and so it's not fair for people to come in late and join the game. We want certain members to start together and end together as a group. And not every game is like that, but I think some games like that. And so this gen server will be attached to this space. So this is an example of server side, let's just call it gen server. Another example might be the red light, green light itself. And so we're going to have maybe a supervisor of spaces at the very top. It's started by the root application. Starts one spaces supervisor that supervises everything. Supervises all the spaces. What does it supervise? So it supervises a space singular supervisor. And so this is so a supervisor has a singular duty, which is to watch workers, and when a worker dies, it will respawn that worker. So if the space has a bug and blows up, the spaces supervisor will recreate the space supervisor. And a space supervisor will supervise any, I guess these can be considered plugins or games. So for the red light, green light experience, maybe it'll spin up the space supervisor, and this supervisor will spin up something that manages the game. So this would be something that we kind of already coded a little bit before. Oh, somebody said they've entered. Okay, let's keep track of them. Give them a new account that has 100 health, and but maybe even this, you have that kind of like observation deck where they haven't said they wanted to play. So they can have a state that says, I'm not playing, I'm just here looking, right? Then in this supervisor, we can broadcast a message to the front end that says, create this button that says, we want to, if you want to play, click this thing. Then when the front end, you click this thing, it sends a message back to the back end, and then it goes, oh, okay, I'm going to change your state to playing now. And then when enough people have come in and they say they want to play, we can send a message, teleport everybody who said they were playing to this entity, to this spawn point, which we can also create. So this thing can also specify the spawn point. So I'm trying to keep the logic all together where this thing has the power to send messages to the front end to create those objects, spawn point, create these things that I need you to create that I'm managing from the front end, from the back end, and you're drawing it from the back end. So within there, we'll have the red light, green light, which will have logic like, let me draw the floor and I'll control the color of it. You draw it for me. And then I'm keeping track of all the movement. So whenever I'm subscribed to movement. So here's the condition. So if my state is red light and you're playing the game and you've moved, then I'll send a message to everybody that says this person has died, and then I will send a message to teleport you over here.
So wait, you said all of that is happening on the server side?
The logic is happening on the server side, but the messages for certain things are coming in from the clients, like movement,
Yeah.
or
Okay.
the fact that they clicked on this thing that says I want to play now.
Okay.
But the logic of I have to know, I'm constantly watching for the changes on the back end that says you are playing, the state is red light, and you moved. So now I send another message which causes changes there.
Okay.
So what I haven't done before is the supervisor of other supervisors. So
do you need one right now? I mean, if you just have one space, you don't need space as supervisor. Deal with that later, right?
Yeah, I mean, well, we have 15 minutes left. What would we like to do here?
Well, did we finish the entire server-side architecture?
So I was in the middle of writing this. Do we have any questions, or we can expand on this a little bit more? So, I think one really cool one would be the kind of Star Trek bridge experience. So we can have a space supervisor is a ship, right? So then the three of us, we could go to the URL, the xr.space/enterprise, for example. So we'll be on the enterprise. And then maybe three other friends of ours go on the xr.space/Artemis. And they're on two different spaces, but each one of them has a gen server which is keeping track of where they are in the universe. So it's like maybe ship 1 is at 000 and like ship 2 is at 111, and then so we're adding events like, oh, when you press this button, we'll simulate that because we're not actually moving, right? You click a button, but in the screen we're making stars go past, and we'll send this information from one gen server to another gen server that, oh, I'm going from 000 heading to 111, right? And on their side, since it's getting that messages, would draw a little spaceship which comes to their location. So right, it's almost like we're in that shared universe, and then we can open up a communications channel to actually throw the message on screen to like patch in the audio, right? If we get them on the same channel, so I think that would
So
be
wait, that wouldn't be a single game. That would be more than one game.
yeah
Hmm.
yeah. So I think every ship would be an independent game, because if you're far away from each other, there's no reason to anything about each other, right? It's only when you're close to each other in that universe coordinate space that you even draw each other, right? Otherwise, you're off fighting your own monsters or whatever. But you could fly in parallel to a place, right? And so it'll look like kind of like what Bobby has in his background there, right? He's got a spaceship there, and we could all have our own. We could all have our own spaceships, and each gen server is keeping track of your own fuel, your own weapons, your shield energy, right? So we could fly each other, but we're all maintaining our own state. And if one person gets destroyed, we just kill that gen server, and somebody else could jump in. So I think it's a pretty good data model for independently controlled bits of state. I think it's pretty cool to do it that way.
Do we want to focus on one game or one thing to do first, and see what the spec will be like, what the logic would look like then? Because I feel like we're sort of going from red light green light to maybe presentation mode, and then to spaceship. Obvious spaceship is kind of
I think
that's gonna wait, but like
yeah. Let's do the slideshow first, because we have to come out with a specification. And actually, I thought red light green light would be easy, but it turns out red light green light is hard because you need a message that doesn't originate from any client, right? No client is saying red light green light. That comes from somewhere else. So I thought it would be the easiest one to start with, and it's not
but
that easy.
okay, even
Like,
that. What if there's no server message? What if each client simply just needed red light, green light? And then as long as this client, me, I move, I lose. They don't have to all talk to each other, right?
but what changes the red light to green light?
If the client side, each client, like imagine you have a red light, I have that, and then Bobby has this too. We're basically playing our own game. Like you said, if it's like spaceship, I just need to send that message when I'm destroyed. You guys need to be aware of it, or when I move, you need to be aware of it. Isn't that just sort of pretty similar?
Yeah, but what's
Like,
what's coordinating the same? It's not fun if we're all getting random red light green lights. We want to all escape the red light at the same time. So something has to synchronize that, right?
yeah, okay.
Right,
So
or else Homan will be moving
yeah,
when I'm red.
I'll be moving when it's red. It won't make any. Yeah. So
Yeah.
that coordination is like I went through like, oh, should we elect one person to be a leader that they demonstrated? But then I thought that's not fair, and also your game will die if that person disconnects and
Yeah.
you have to elect another leader. So that that makes that introduces like additional complexity. So there are also models, because I've been looking at other people's code base recently. There's something called XR Frame, which is written in Three.js, and what they do is they run the same code on the client and the server. So they
Yeah.
have JavaScript on the front, a full JavaScript engine on the back, but then they set up Kubernetes and not Agora. There's some other system they set up on top of that which launches that. And I felt like that's kind of overkill because we really only need um, these lightweight processes to send these messages. But you're right that the advantage they have is they can write the full stack in the same language. So it has
Yeah.
that advantage. Whereas this, you have to shift between like JavaScript land and Elixir land, but it's also kind of not new for web development because we commonly have to do that. There's like HTML and CSS and front end, and then you have like data.
But gaming is a little bit different though. Like everything is changing all the time, and you want to be able to make the experience better in the sense that you want to process as much stuff on the client side as possible, but at the same time you want to keep all the clients in sync with the server. So if you have the same list of events that you want to process, I think it will be good. And then the server guarantees the order, but on the client side, you just process them, and then you process the same thing on the server side with the exact same logic. Then you will sort of have the advantage of being able to look faster or feel faster because everything is on the client side, but at the same time make sure that nobody cheats because people cheat from the server side. So like there's some advantage to that. I think I've read some articles on how to do that, and this was the conclusion, right? Like to be able to have this run the same processor both in the client and on the server side, and have server be the source of truth, but also aim so that your clients and server almost never go out of sync because they're running the same things. And if they actually go out of sync, now we know we have the source of truth. You push the changes to the clients again, and clients will be caught up.
Yeah, I mean, I think the advantage is you're running the same language there, but in terms of constantly being in sync, there's still issues. Like you can't expect to push the exact frame rate out. So you're really just sending.
Yeah, you don't need to, right? Like there's a rate that you push things out on the server side. There's a rate, probably a much faster rate that you do on the client side. Right, like server you can do once every, let's say, 100 milliseconds, where client you can process every 10 milliseconds, right? So it's 10 times faster on the client side versus on the server side.
Yeah. Well, I think coming up with the slideshow specification is a good place to start.
Yeah, I agree.
So,
We still haven't talked about like the assets. Like where do they live? Like is there a way that what happens when I specify a component? What was it called? An entity that I said this is a slide has this image, but that image it has to be uploaded somewhere, right? Like what do we do there? Like
can I extend the call? Be more productive. Try it.
No, you have to pay to extend, I think. Yeah, they're all trying to make money, man. I was at the resort. It's like unbelievable. Like these corporations are just coming up ways to sort of just charge you.
What was your question? Are you talking about in the specification you define you want to?
Yeah, like obviously I would have slide 1 green, slide 2 red.jpg, green.jpg, step 3 perhaps some animation, some GIF, right? Like like the green.jpg, red JPEG, yellow.gif. Where do they live? How do we tie the two together again? Like, right?
Oh, where are the assets? Where are the assets stored?
Yeah.
You upload them. So we create a file uploader.
Okay, so that's another part of our application, right? Like allow people to upload. Like, yeah, so I think I've seen that. I think
or it's a
URL.
Have. I mean, you can host it yourself.
I see. So okay, so it's like an image tag.
Mm-hmm.
HTML. Gotcha.
Image source, right?
Okay.
Right. This is a new code base. It doesn't have that. I have that in the VR Meet code base, but they have tutorials in the Phoenix Live View for doing image upload and all that kind of stuff. And I think that to start off with, the menu system in VR is harder to create than the HTML menu system, right? Because Phoenix is kind of built for flat menus. So in the beginning, we can just, when you're in VR and you want to like add an asset or something, you can just pop back out to 2D mode, then get an iframe, and then you can use that, and then you just click the glasses and you can jump back into to start with, because it's actually, there's no way to put an iframe inside VR using Babylon.js right now. And you can create simple menus, but they require a separate syntax, and you have to create them all by hand. So unless we have a programmatic way where we can get data and then manipulate them onto textures, and then those textures have to be like clickable, like you have to define buttons on them, and then you have to make them scrollable. You're almost defining like a new DOM for VR, which is kind of hard. So yeah, I created a channel for the XR, so I'll just keep picking on this and I'll upload videos on that. Yeah.
Cool. What are you doing for the holidays?
I'm going to have a Christmas dinner with my parents. I'm gonna make a rib roast.
Oh, you haven't. I thought you were going to do that for Thanksgiving.
I made a turkey for Thanksgiving. Well,
Oh.
here, let me stop recording this.